Again, this is about Maclaurin series expansion, and if you look at the MF 15 formula sheet given in the A-level exam, right, these are actually sin x. We have this sin x expansion, x minus x cubed over 3 factorial plus x5 over 5 factorial minus and plus minus 1 to the power r x2 to the power r plus 1 then 2r plus 1 factorial. Nope, let's just write it properly. 2r plus 1 factorial. Okay, so make sure everything copied correctly. This is the expansion, and then we have the ex, the expansion, right? The expansion for standard series expansion for 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus all the way to plus xr to the power r factorial, and so on and so forth. So let's say if we want to do expansion up to the first 3 terms, what do we do? Eventually we will have our answers all in x. But let's say, okay, there is a, okay, remember this is okay, so ex, I want the first 3 terms, right? So I just change this to first 3 terms plus x squared over 2 factorial. Okay, and then here I also take just the first 3 terms of this expansion. But what is my sin 2x? My sin 2x is just, you replace with 2x here minus 2x cubed over 3 factorial plus 2x to the power of 5 over 5 factorial, and we will get 2x minus 8x cubed over 6, 326, so plus 32 x to the power of 5 over 5 for 20, 20 times 3 60, 60 times 2 120, so 120. So this part will be this, so I'll just substitute in 1 plus 1 come from here, sin 2x, the expansion is 2x minus 8x cubed over 6 plus 32 x to the power of 5 over 120. So likewise, so if I do an expansion and get the first 3 terms, I think what would it look like? It likely come out to x cubed, and we can ignore this, likely be able to ignore this term. So let's see, let's say we multiply 1 to all this, right? 1, we'll get 1, right? We just see, what I suggest is to get all the powers here first, right? I will get x squared term as well. So I will actually only need to care about up to the x squared term, because we only want the first 3 terms including the 1. So which will give us the 1. 1 times 1 will give us 1. Is there any other terms that will give us constant? No, because x times 2x, the moment x times 2x is 2x squared already. So, and 1 times 2x will give us 2x. So there's no way to get another constant number. So this is our only constant number. So we proceed. So what is inside here? To get the x, okay, 1 times 2x will give us an x. So 1 times 2 is 2. So I leave it here. Right, then x times 1 will give me 1. Or will give me x. So I add a 1 here. Right. And then is there any other way to get an x? No way, right? 1 times 2x or x times 1, that's the only way. Is there any other way? No, so likely we have 3x. If you're not comfortable with this kind of expansion, you can do the slowly step by step. For example, 1 times 1 plus 2x, since multiplied by 1, every term will have. Okay, we likely need to, we only stop, we know that there is an x squared term, so we can stop at here. So 1 multiplied to this and this, and then x, when it multiplies, you multiplies to x plus 2x squared. x4 term, not likely, we don't want it. So when x squared we go to here, then we will plus x squared over 2. And do we need the x cubed term? We don't need, right? Because we will have 3 terms already. So 1 plus 3x plus 2.5. So 5 over 2 x squared. This will be our answer. But let's say if we do it this way, we also get the same thing. So x times 2x will give us 2x squared, so we want the 2. And x squared times 1 will give us x squared over 2 times 1 will give us the x squared term. So we want this half. Is there any other term that will give us x squared? Okay, 1 times x squared over 2 will give us, yes, so but that we already done it. So is there any other term? No, yeah, no. So there will be 2.5. The same thing that we get here, 1, 3, 5 over 2. I would say doing this method can be tricky for some people, so if you want, you can do it this method, which is safer. So but both of them should give you this as the answer. So that's it. This is the expansion for this one last. Okay, no, here, this is the answer. Okay, that's it.